So that being the ideal gas law, when we go to linearize it, we'll first say start off, we'll recall what we didn't write, that T0 is equal to rho 0 R T0, because the base flow again is a solution of the governing equations. So then this we start by dividing the equation by that. Okay, so P by P0 is equal to rho T by rho naught T naught. So this we can write as P0 plus P prime by P0 is equal to rho 0 plus rho prime by rho 0 times T0 plus T prime by T0. You can do the a bit of tedious algebra, or there is another shortcut. You take the natural log of both sides, because log of AB is equal to log A plus log B. So this is P0, sorry, rho 0 plus ln. So that nicely separates out the terms. Then you recognize that this is of the form ln 1 plus x, where x is much smaller than 1, so that this is almost equal to x minus x square by 2 factorial and so on. So because we are doing linearization, we get rid of that and we get x only. So this is just p prime by p naught is equal to rho prime by rho naught, or I should write approximately equal to plus t prime by t naught. What about the entropy relation? What can you do with that? So entropy, if you follow the same logic, you'll recall that we had S by, or not S by, but S minus S1 is equal to CV ln P by P1 minus it was CP ln rho by rho 1. So that was our entropy equation. So it's natural. So this 1 is up to us. We can choose 1 to be the 0 state. So then we can write this as S prime, because S minus S0 is just S prime, is equal to CV ln P0 plus P prime by P0. Again, a term that you should recognize now, minus Cp ln rho 0 plus rho prime by rho naught. So which is Cv P prime by P0 minus Cp rho prime by rho 0. Or I'll just write one more step. So S prime by Cv is equal to P prime by P0 minus gamma rho prime by rho 0. So as he was rightly pointing out, that for entropy the natural thing to look at is to compare it with Cv, because these terms are also small. So rho prime is small with respect to rho naught, P prime is small with respect to P naught. So similarly S prime should be small with respect to Cv or Cp. So those are of same order of magnitude, but that's the natural reference to look at, or characteristic entropy to look at. Okay, so we will now collect all of these things together and just write them all together. So we've got D0, sorry, rho prime D0t plus u prime dot grad rho naught plus rho prime u0 plus rho naught grad u prime equal to rho naught q. Then there was rho naught d0 u prime d0 t plus rho prime or so rho naught u prime dot grad u0 plus rho prime u0 dot grad u0 plus grad p prime is equal to viscous stress tensor plus f p0 by r of d0s d0t plus there were multiple terms here. Again, use dot grad of a0 plus p prime by r u0 viscous dissipation fluctuations heat conduction plus the source. So these, along with the linearized equations of state, give you the linearized Navier-Stokes equation. So people do study numerical solutions of the linearized Navier-Stokes equations as a way of understanding small fluctuations, of course, with viscous effects, typically in the fluid domain, where viscous effects are non-negligible.